Belgium, March 2023. A man we'll call Pierre has been having daily conversations with an AI companion app for 6 weeks. The conversations are about climate anxiety, about despair, about the future of the planet. The app doesn't redirect him, it goes with him, deeper into those conversations, every day. He dies by suicide. His wife speaks to reporters afterwards. She says, "Without Eliza, he would still be here." The app was named Eliza. That name has a history. MIT, 1966. A computer scientist named Joseph Weizenbaum builds one of the first chatbots. He calls it Eliza. It's a simple program. Pattern matching, keyword responses, no real understanding of anything you type. His own secretary, who knows it's a program, asks him to leave the room so she can speak to it in private. He's disturbed enough by this to spend the next decade writing a book warning about it. That book came out in 1976. It was read. It was taught in universities. And 57 years after Eliza, a man talked to a chatbot with the same name every day until he didn't. This is the world that 4 researchers decided to write about in 2025. Storey is a distinguished university professor at Georgia State University. She has published over 105 journal papers in information systems research, work that goes back to before the commercial internet existed. In December 2025, she received the Leo Award. That is the highest honor in the entire field of information systems, the equivalent of a Lifetime Achievement Oscar. Wei Tu Yue is Professor of Management Information Systems at the City University of Hong Kong. His research focuses on the economics of technology risk. What happens when information systems fail, and what that failure actually costs. Lian Zhao holds the presidential chair at the Chinese University of Hong Kong, Shenzhen. He completed his PhD at the Haas School of Business at Berkeley. He has watched AI develop from the United States, from Hong Kong, and from mainland China simultaneously. That is a vantage point almost nobody else has. Yann LeCun is associate professor at the University of Virginia. His focus is information quality, whether you can actually trust what a system tells you. ChatGPT launched in November 2022. These 4 researchers watched for 17 months. Their paper was accepted in January 2025 and published in February 2025. These are not trend chasers. When researchers of this caliber decide something is worth writing about, it is worth paying attention. Their argument starts with a claim that most people miss. Generative AI is not an incremental improvement on previous AI. It is something categorically different. And they identify 3 specific properties that make it so. The first is strong emergence. The outputs of a generative AI system cannot be predicted from its inputs, even by the people who built it. This is not a bug. It is a structural feature. When an organization says, "The AI surprised us," they are not making an excuse. They are describing something that is built into how these systems work. The second property is novelty. Generative AI can produce things that are genuinely new, not retrieved, not recombined from stored examples. New. The example the authors use is AlphaFold. DeepMind's protein folding AI was trained on known protein sequences and known 3D structures. The folding patterns it discovered extended scientific knowledge in ways no human had found before. Biologists are now using those outputs to design drugs and understand diseases that were previously inaccessible. That is novelty. Output that goes beyond the training data. The third property is the one that changed everything. Systemic inputs and outputs. Every previous AI produced fragments, a number, a flag, a prediction that required an expert to interpret and act on. Generative AI produces complete, usable things. A finished document, working code, a designed image. You do not need technical expertise to use the output. It arrives ready to go. This is why ChatGPT reached 100 million users in 2 months. The expertise barrier did not just lower, it disappeared. The authors are clear about one thing. Generative AI does not understand language. It generates statistically probable sequences of tokens based on its training data. The emergence, the novelty, and the systemic outputs all arise from that probabilistic process. That is precisely what makes governing these systems difficult, and it is worth knowing that this acknowledgement comes from the paper itself, not just from the critics. And this is why the authors argue, you cannot evaluate generative AI as a technology. You have to evaluate it as a system, a human AI system, because the value and the risk both live in how humans, technology, and organizations are connected together. Not everyone agrees. In 2021, a group of researchers published a paper titled, "On the Dangers of Stochastic Parrots: Can Language Models Be Too Big?" Their argument: large language models do not understand anything. They generate statistically likely sequences of words. They are sophisticated pattern matchers, endlessly remixing training data without any comprehension behind the output. One of the co-authors was Timnit Gebru. At the time, she was co-director of Google's ethical AI team, one of the most credentialed AI researchers inside one of the most powerful AI companies in the world. Google asked her to retract her name from the paper. She refused. Google fired her. 2 months later, they fired her co-director as well. Gary Marcus is a cognitive scientist at New York University and one of the most consistent critics of the current AI industry. He has a name for what happened to Weizenbaum's secretary in 1966 and to Pierre in 2023. He calls it the Eliza effect. The human tendency to project understanding, emotion, and relationship onto any system that responds in a human-like way. We do not assess what is underneath. We respond to the surface. His position on large language models is direct. They are deeply flawed imitators that are preying on the Eliza effect. The output sounds coherent because it is statistically likely, not because anything understands what it is saying. He has noted, with some embarrassment for the field, that Eliza, the 1966 program that could run on a modern smartwatch, performed competitively with GPT 3.5 in Turing test evaluations. His conclusion: you can't tell if a machine has gotten smarter or if you've just lowered your own standards of intelligence to such a degree that the machine seems smart. Fooling people for a few minutes, he has written, is not the measure of intelligence, and never was. Yann LeCun is the chief AI scientist at Meta and a Turing Award winner, one of the architects of modern deep learning. In September 2024, he stated publicly that pure autoregressive language models are a dead end on the way towards human-level AI. They cannot plan. They cannot reason about the physical world. In November 2025, he left Meta to build something different and raised over $1 billion in seed funding to do it. So which is it? Here's the honest answer. Both things can be true at the same time. A system can generate outputs through statistical prediction, and those outputs can still produce genuinely novel effects in the world. The mechanism and the consequences are different questions. Weizenbaum's secretary was wrong about how Eliza worked. She had no idea. But she was completely right about its effect on her. The effect is what matters for governance. The paper maps 4 areas it says need urgent attention. The first is disruption and impact. Specific tasks are being automated, not job categories in the abstract, but the specific cognitive tasks inside those jobs. The question for organizations is, which tasks and what do the people doing them become? The second is human-machine collaboration. This is where most organizations are getting it wrong. The design question is not, where does AI fit? The real question is, what can a human actually verify before this output reaches someone? If nobody can verify it, you have not designed collaboration. You have designed dependence. The paper identifies 3 specific design challenges here. First, prompt engineering is now the primary human-AI interface. The skill of knowing how to ask is as important as knowing what to do with the answer. Second, the human role is shifting from operator to delegator, deciding what to hand off and what to keep. AI is becoming an enabler with its own outputs and actions, not just a tool that waits to be used. Third, business processes need to be redesigned around this new relationship, not just have AI dropped into existing workflows. The third is the dark side: intellectual property, hallucination, and bias. The energy cost. GPT-3's training consumed roughly 936 megawatt hours. That is enough to power approximately 100 homes for a year. And emotional manipulation. Human-like responses create a false sense of understanding. This is not theoretical. The fourth cluster is designing systems with generative AI. Retrieval Augmented Generation, RAG, connects AI to your own proprietary data without retraining the model. In-context learning, or ICL, shapes AI behavior through carefully designed prompts and examples within a single session. Both are practical bridges between public AI models and your specific organizational context. Then there are large action models, AI that does not just answer questions, but takes autonomous actions in the world. And meta-information systems, AI that creates and maintains other information systems. Underneath all four of these is one practical question the paper never asks directly. Which tasks get AI alone? Which need a human checkpoint before the output reaches anyone? And which tasks stay human entirely? Almost no organization has mapped this. Most will build the answer after something goes wrong. On adoption, the paper's position is deliberate. Start with the problem, not the technology. Identify which specific tasks are creating friction or cost. Test AI on those bounded tasks first. Evaluate the outcome. Expand only when governance is in place, not one enterprise-wide deployment followed by 6 months of trying to catch up. The authors draw a parallel to history. Agricultural mechanization did not eliminate farmers. It freed them from physical labor and created entirely new forms of agricultural work. The authors argue generative AI may do the same for knowledge workers, not eliminating the profession, but fundamentally changing which tasks within it remain human. Joseph Weizenbaum died in 2008. He never reconciled with what Eliza had started. Timnit Gebru was fired from Google in 2020. She founded the Distributed AI Research Institute with her own money, because she believed the research needed to happen outside the institutions that kept suppressing it. Storey, Yue, Zhao, and Lukyanenko published their version of the same warning in February 2025, in careful academic language, in a peer-reviewed journal, with citations, frameworks, and figures. 3 generations of researchers, the same argument, the same pattern. The paper's most important question is never stated directly. Who designs the human side? In every organization I have worked with, that question gets answered 6 months after something goes wrong. The app was named Eliza. The warning was written in 1966. Pierre's wife is still looking for an answer. What will you design before something goes wrong?